I want to talk. So I talk about the tunneling. I want to talk also. I want to go into talk about some of the client side load balancing and what we're doing. But in order to do that, I first need to set up an HA setup. So let me we'll talk through some of the etcd management stuff. So what I'm going to do is I'm going to set up a 3-node highly available cluster of K3s. The way this works is it is going to run embedded etcd. This, I'll demo this. This should be the easiest 3-node Kubernetes fully HA setup you've ever seen. This should be pretty simple. But in order to do this, I'm going to kind of clear the state of everything first. So again, like I'm going to do here, I'm going to shut down K3s agent. Let me just say K3s kill all, and I'm going to wipe out the. So I'm going to just kind of start with a new cluster here. So I'm going to wipe out Rancher K3s and do basically the same thing on the first node here. I think I can just run K3s kill all. That should shut it down too. Then wipe out, oops, I'm in that directory. Then wipe out var lib rancher. Okay, so I should be back into a clean state. So in order to set up a 3-node cluster, the one tricky thing, and it's kind of hard to automate. Like one day we'll hopefully find an easier way to automate this, but there's in order to bring up a 3-node cluster, you first have to initialize it on one node, and then you join the other nodes. So to initialize it, what we're going to do is we're just going to go into, here, I'll show you from the help first. K3s server help. Okay, so it's this one, this parameter here, this cluster init. We need to drop those. This is not experimental in any way. This is well supported at this point. Yeah, these shouldn't be marked as experimental. Cluster reset. Okay, sorry, not reset. Reset. That's when things go really bad. I can show you reset if you want when we're done. But so cluster init. So what we're doing is on this node, we're going to run the init. So again, I like to use the config file. So edit this config file, and we're just going to say cluster init. Since this is a Boolean parameter, what I want to type on the command line is that the way we express it in the config is as a Boolean. So we say cluster init true. Okay. So then now when I bring up start K3s, so we're going to start up K3s just through systemd here. The reason why this just the reason why when you type start it waits a little bit is we have systemd integration into K3s where we wait until kubectl is fully available before we say the unit is started. So basically we're guaranteeing that right after the K3s start, as long as that exits correctly, you can immediately start running kubectl. So this makes automating things a lot nicer because you don't have to run some other type of thing where you're waiting for kubectl. But it doesn't guarantee that Kubernetes is fully initialized. We're just making sure that kubectl works. But things are still usually booting up. Like if you say get all like this, yeah, say for example, this one's not ready yet. But whatever, that was just 9 seconds ago. So this will become ready probably by 15 seconds usually. Yeah. Okay.
Aaron, a couple of quick questions before you move into further detail. Alejandro has asked if it's possible to generate a token before installing all of the nodes. So rather than have to wait for the master to come up with and generate its own token, can we inject the token into all nodes at the same time and bring everything up at the same time?
Yes, you can. So when you run server help here, what you can do is just basically, you just specify the token yourself. So if you don't specify the token, so where's the parameter? Not agent token. Towards the top. Token here. Okay. Token or token file. So this is a shared secret used to join servers. So you can just specify some random value. Okay.
There's no minimum specification or?
What was that?
There's no minimum specification or format that has to be?
No, it's a string of characters. We don't really care. Don't put
Okay.
spaces in there, or don't put white space. But just some characters. Yeah, so it doesn't matter. But I will say this is something we're trying to improve, is that right now, if you grab this one, you can see this has a bunch of crap in it. It's like formatted a certain way, because this token is actually more secure. It does more validation of some of the cryptography crap than if you put in your own token. And we're trying to improve that so that people can specify their own token, but it can still be as secure as these tokens. This has to do with like, when we start up K3s, we have to generate a series of CA certificates. If you know how to generate the CA certificates, this value here is right after the K10 is actually a hash of the CA certificate. And so, yeah, so we're actually hashing the CA certificate. So we're doing like a trust, trying to trust the TLS up front. So this node token approach is more secure than doing a shared secret.
Okay.
But the shared secret works too.
Okay. Thank you for that. We've got a few questions.
Sure, go for it.
Everyone's loving this. So next one, what does cluster init actually do?
Right. Okay. So cluster init. So this is because by default, because K3s is very heavily like people use it a lot in a single node setup. That's probably the most common use case for K3s is single nodes, or like a single node cluster. So cluster init tells it to like don't use the internal SQLite implementation. Instead, use the embedded etcd, and then it initializes the etcd database, because etcd is a raft-based consensus system, and so you effectively have to initialize it in one place, and then everyone then joins in. I mean, there's ways kind of actually to do that across a bunch of them, but this initializes etcd effectively and puts it into the mode of we're going to be running etcd all the time.
Okay.
Can I sort of tag along on that question where Agor has asked, is it possible to migrate from a standalone K3s node to an HA K3s cluster? No.
And this is like a big gap right now. I mean, I was literally before this call on top, like talking to the engineering manager for K3s at SUSE here, of like, we need to get this, because so unfortunately there is no, if you have a single node, you cannot move to etcd right now. Yeah, it's unfortunately like there's not. So like we're trying to just, so before before we did etcd, we had dqlight, and it worked with dqlight. It was very simple. We could move from, because dqlight was also a SQLite based thing. So we moved from kind of like one SQLite implementation to another SQLite, and so it was very easy to upgrade. But etcd requires us to do a little bit more manipulation of the data to move from one style to another. So unfortunately, it's not there. It really bugs me, and so I'm glad you brought that up, and I really hope we fix that soon.
Okay, and the final question we've currently got open: for what functionality is K3s using IP tables?
Oh, well, I mean, that's Kubernetes, like, and crazy. Kubernetes is its own little mini service mesh of like Kubernetes does, moving all this data, like private networking and port forwarding and all of this stuff. And so the kube proxy is the one that uses IP tables. So we don't directly, like K3s in terms of like the K3s specific code does not interact with IP tables. It is Kubernetes that uses IP tables, and specifically it is the kube proxy which uses it. If you're like, I hate IP tables and I don't want to use IP tables, then there's other approaches like KubeRouter or Cilium, where you can drop the kube proxy completely. This is getting more advanced territory, where someone could drop that and use non-IP table based stuff. But at the end of the day, Kubernetes has to move around a lot of traffic. It's got to doing a lot of natting and stuff like that.
Perfect. Thank you. That's the end of the questions.
Okay, so let's see. Hopefully we started up, right? Cube, CTL, get node. All right, so at this point, I think I'm grabbing I need the node token. Since I wiped it out, it's now got a new node token. So, oh yeah, so we can see here the roles now is control plane, etcd, and master. Kubernetes, like I'm running, I believe version, this should be 120. I think that's the stable right now. Yeah, 120. So Kubernetes is going through a transition right now where they're deprecating the term master and moving to control plane. So that's why you see three things here, but control plane and master are interchangeable. Eventually the master will be removed and it'll just be called control plane. Okay, so, no, sorry, go back, copy that token. So here now I'm going to oh, you know what? I need to just completely uninstall K3s because I installed it. K3s. Wait, did I uninstall? User local. Oh, I didn't realize that. It's called K3s agent uninstall. Let me just completely remove it because this is no longer going to be an agent. Like K3s runs in two modes. It's like a server or an agent. So for a highly available HA cluster, I need 3 servers. And then you can have as many agents, which are the worker nodes. So in this situation, so I'm going to set up 3 servers. So that's why I'm just completely uninstalled that. So if I go here, K3s, oh yeah, and the uninstall will wipe out the directory. Rancher, K3s. So I'm just creating this directory, and then we're going to edit Rancher K3s config YAML. And here we want to put the token. And again, we want to put the server URL, which let me go back here and get the IP. It's going to be this private one, 6443. Okay. So now that I have that config in place, let me install K3s again. And so I'm just doing the default installation because the config's already here. And then while that's installing, that should take, maybe 30 seconds or something. I can watch the logs here of K3s. Oh yeah, it looks like it's already. So you'll start seeing some messages here from Raft. Okay. Yeah. Okay. So this is the one I want to show you here. So the way we're managing etcd is super cool. I'm super this is all. The team has been working very hard on the etcd integration for quite a while, trying to make this rock solid and simple. And so the way it works is when you join a new server and we put it into learner mode. And what learner mode is it looks at the current state of the etcd cluster, like the Raft log, and it will replicate over the entire log. It's learning the whole state. So while it's learning, that does not impact the etcd's ability to change state. Like before we had learner mode, that it would actually cause issues of blocking writes, I believe. But now with learner mode, it doesn't matter like how much state is in etcd. We start the nodes in a learner mode. Once they learn the whole state and they're like now in synced, we then flip it over to a real participating member of the cluster. So now at this point, if I go back here, say kubectl get node, yeah, so you can see we have two running. Okay, but we only have 2, which is bad. In a quorum based system, this is like 2 is actually worse than 1, whereas 3 is good. So this is like you don't want to have 2 because that. So anyway, so we'll now set up the 3rd one. So in order to set up the 3rd one here, we just need to replicate the configuration. Config, K3. Oh, no, why did I do that one? On the config, not that. Okay, so we're just going to replicate over this configuration here. So now I'm on a 3rd node. Same deal. We're going to create this directory, Rancher K3s. Then we're going to edit. Oops, type Rancher, right? Okay, and then, man, trying to rush. Okay, so we're going to put this in place. So we put this same file in place. Okay, now, again, K3s.
Someone said learner mode sounds confusing. I don't know if this is a correct way of explaining it, but maybe it might sort of help it in different terms. It's like MySQL replication where it replays a transaction log to try and get you back to the same state.
Right. Because it's like
is that sort of a correct analogy?
That is effectively a correct analogy of like, it's like doing the bin log streaming or replication because the way Raft works is like, it's just a log of mutations, of changes, of like change. So it's like just one, like you're just kind of tailing something. So the problem is when you add a new one in, what we need to do is we just need to tail the end of the log, but I can't tail the end of the log until I have the beginning of the log. So when you do the learner mode, it's basically it's piping over the entire stream of the entire log until it learns the entire thing before it starts participating. Because if it tries to participate before learning it, it effectively cannot confirm a write until it's learned the entire thing. And that'll effectively halt the whole cluster, and then chaos ensues. Okay.
Fantastic. We've got a few more questions as you asked for them to be during the time.
Go for it. Yeah.
Okay. Is there a difference between the kill all and the kill agent script, or is it just literally naming?
It is named different. I don't know why we did that, to be honest. It would be better if it's just all K3s. Yeah, because so I think, well, no, that's probably not true. I wonder if there's any difference. I don't know, actually, because the agent script was that was introduced a little later, and I don't have hands-on knowledge of it. Yeah, sorry, actually, I don't really know.
Okay. The next two questions are kind of related. So one person asked if they specify cluster init when initializing the installation at first, it then won't use SQLite, so then later on you can go to multi-master.
Yeah.
Correct? And another user has asked, is there a negative performance implication for running a single node?
Yes, there is.
In it?
Yeah, and so we've tried to document this a little bit. So there is a downside of, I think it's Rancher docs. Let me see if I can find it. There is a downside of like etcd does require more resources. That's why we use SQLite for single nodes setups. So there's somewhere in here. I don't know. I don't know where it is. It's somewhere in the docs. We actually embedded with embedded DB. Crap, I don't know where it is. We've documented this somewhere. Maybe someone who knows can point it out or something. Is like there's somewhere where we talk. There's a little bit more memory. It takes a little bit more memory than SQLite. But then the more important one is it highly increases the number of IOPS. Like etcd is doing a lot of F syncs to the disk, and it's kind of constantly doing it. So what you'll see is like if you want to run this on a Raspberry Pi, etcd will just like kill an SD card. So SQLite is it's like works much better. It's like much lighter weight on the disk. So if you do care about more lighter weight, lower resources and whatnot, then that's why you're going to want to stick with SQLite. And that's why SQLite is still the default, because etcd does add, this overhead.
Okay. Two more questions. Can we set up and bring down a highly available cluster in one go instead of configuring each node?
Well, that's where it gets like a little tricky to configure, because like as I said, like you have to have like init one and then join the others. And so the way people typically do this is it's kind of like a bootstrapping procedure of like let's say I was doing this in like Terraform or something like that in the cloud. What you would typically do is kind of like create a cluster init ASG that has one, or like just a VM. You don't have to do an ASG, but like you just have one VM that's the init node, and then you create like 3 nodes that will join the init node. So you have a 4-node cluster, and then you delete the init node. So it's like it's kind of crummy. Like it's a super hard problem to bootstrap, because in order to bootstrap, the bringing up a clustered system requires effectively another consensus. And so some things like console does a good job of this, because like they kind of already have they have a lot more interaction with the internal state or whatever. So we're trying to improve this, but like right now it's kind of a little tricky to automate bringing it all up.
Okay.
But there's a lot of Google around. There's a lot of people who have tried different scripts and automation. We have Terraform scripts for it too, from Rancher. I don't know where those are off the top of my head, but they're out there and stuff.
Okay.
Or just use like Civo Cloud.
Absolutely, make it easy. Can I join a virtual kubelet worker node to K3s cluster, or is it in the roadmap?
Yeah, it should work. Yeah, you shouldn't have any problems. Oh, actually, let me point out, this is totally random enough point. There's this project called System K, and this is no, actually do want to search for System K. Let's see if I can find it, because it just moved. It's now nope. Gosh darn it! It just moved because now it's, where is it? Yeah. Yeah, this one. Okay, archived. There you go. Now it's, yeah, this, because this has moved to the virtual cubelets. Okay, so this is a super cool project. Even though like I can't stand systemd myself, but it's like such a cool use of technology of like what this project is doing is you run a K3s control plane, and then you create virtual kubelets that interact with systemd that are actually creating systemd units and installing like Debian packages. And so you're managing systemd as a virtual kubelet through Kubernetes. It's like, I don't know if there's anything practical use case to this, but I just thought it was an amazing use of technology. And
we talk about turtles all the way down, right?
Yeah. I mean, whatever. I mean, it's, yeah, like I love this stuff. I like, but it's, I tell you, it's like always the most ridiculous ideas that like, it was like, oh, it was a hack, and then we did it enough, and we're like, nope, now that's best practice, and it's good. So anyways, so yes, virtual kubelets do work with K3s, and it should work. And so this is like a decent example of this project. If you want to see how to join a virtual kubelet to it, because this one acts as a virtual kubelet. I think this is like kind of the catch. You just need to figure out like what the kubeconfig is.
Fantastic.
But you can look at the internal files and stuff in K3s and find those.
Cool.
Okay.
The final open question, why have you moved away from dqlight? It looked like it was the way to go for clustered Raspberry Pis.
So dqlight, the problem there is like these graph systems really suck to support. Like the major, like, you know, at Rancher we would, you know, supporting Kubernetes, I don't know, 4 or 5 years, something like, however long, you know, Kubernetes kind of been around, we've been supporting it. And the number one thing of supporting people running Kubernetes is etcd. And it's not that etcd itself is a piece of crap, right? it's that running persistent systems, and especially clustered consensus-based systems, is quite hard. So when it came down to it, it's like, it just didn't make sense to us that to try to stabilize and maintain and support dqlight, because it has a very small community. You know, as a couple developers, or I mean, really one main guy created it, brilliant guy, created it, and it's supported by Canonical within microkates, but it's nothing compared to the community that it exists around etcd. And so even though etcd has been around, you know, for years now, it's very stable. It is still enhancing and adding new features, and we are taking advantage of new features and things that are being added in there that are really helping with like disaster recovery and operational scenarios and all this stuff or whatever. So it's like, when we looked at it, it's like dqlight was lighter weight, etcd added more, you know, it was a little heavier weight, but the pros of the community and the stability, all that stuff outweighed. And so we ended up dropping dqlight. But we had no specific, like, there was no real problem with dqlight in that, you know, it's not that it wasn't, well, it was kind of broke in the implementation we did, but that had more to do with what we did, not dqlight itself. So like that technology and that stuff is fine. It just has more to do with the community and supporting it and what we really felt comfortable with.
Cool.
Okay,
back to you.
All right, so at this point we should have a 3-node cluster. Yeah, okay, so we have a 3-node cluster. So now the whole point is, so I talked a little bit about the etcd management. So again, this is all built into K3s, and also kind of shows of like why what we're doing is significantly more than kubeadm, of like the style of what K3s is. Like K3s actually runs as like a daemon on the host before Kubernetes. It kind of supervises Kubernetes itself. And so we can do things like this, like the etcd management, the tunneling, the whatever. There's a lot of logic in there about how we're transferring around keys, because in order to join a master node, I need the CA certificates. Like right now, if you do kubeadm, that's like, well, copy them somehow yourself. But like we're managing that all for you, and we're trying to do that in the best secure way that we know of. Okay, so let me go. So in order to join an agent now, because I have a 3-node highly available cluster, but now I want to join a worker node. And the reason for this is I want to talk about some of the client load balancing stuff that we're doing. Major, oh my gosh. Okay, config. So in here, I'm just going to put the exact same configuration. Random thing, there is, for highly available clusters, there is actually something like what we're using is the node token or server token. There is something called a agent token that does exist too, that you can specify a token just for agents so that just agents can join the control plane and they don't have the ability to become a server and participate in the server state. And so this is a security thing where, yeah, like because as soon as somebody joins as a server, they have the whole knowledge of the cluster, which includes all the secrets. So I'm joining as an agent, using the agent token, then you only have the knowledge of yourself effectively.